Welcome to Engineering Mechanics video lecture. In this video lecture, I am trying to explain you about solution for given truss problem. I read the problem statement one time. Using method of joints, calculate the axial forces in each of the bars 1, 2, 3, 4, 5, 6 and 7 of the plain truss shown in the figure. On observing this given problem figure of truss, at A end of the truss, hinged support is there. At C end of the truss, roller support is there. By following the free body diagram of hinged support and roller support, we are going to trace the free body diagram of entire truss. This indicates as equivalent free body diagram of truss for the given problem figure of the truss. Considering whole truss as a single unit, using this free body diagram of truss, apply the equilibrium equations. Apply the equilibrium equations along x direction and also along y direction. When you apply summation of forces along x direction equal 0, we can get in the equation of equilibrium RAH only. Why? Because only one force is acting along x direction. So that RAH equals 0 we can write. When you wanted to apply the equilibrium equation along y direction, in the equation of equilibrium we can get RAV, P and P, RC. RAV acting vertically upward direction, so we can consider it as a positive. P acting at D point on the truss is acting downward direction, we can consider it as negative. Other P force of magnitude which is acting at E point on the beam also directing downward direction. At C end of the beam, RC reaction force is acting upward direction. So RC is considered as positive. When we apply all these in the equilibrium equations, we can get summation Fx equals 0. Through that equation, RAH equals 0 we can get. Summation Fy equals 0. Through that equation, RAV plus RC minus P equals 0 we can get. Finally, RAV plus RC equals 0. On observing this free body diagram of given truss, we can say that this given truss is symmetrical about y axis which is passing through B end of the truss. So the load shared by the different supports is equal in magnitude. Therefore, RAV equal to RC. Therefore, RAV equal to P and also RC equal to P we can get. Assume all the axial forces in the truss members as tensile in nature. In each and every member of truss, we have considered tensile nature of force. Tensile force always away from the point, away from the joint here we have considered. And tensile force magnitude also considered. Along AB bar S1 magnitude of force considered. Along AD bar S2 considered. Along BE bar S3 considered. Along BC bar S4 considered. Along AD S5. Along DE S6. Along EC S7 considered. Considering separate free body diagram of joint A, apply the equilibrium equations to find the unknown axial forces S1 and S5 in terms of RAV equal to P. where RAH is 0. In the free body diagram of joint A, S1 force is 45 degrees incline with horizontal. So that we can find the horizontal component and vertical component for that force. Horizontal component will be S1 into cos 45 degree. Vertical component will be S1 into sin 45 degree. On applying equilibrium equations along x direction and y direction, we can get to two equilibrium equations. Algebraic summation of forces along x direction equal 0. Rightward force we consider it as positive. S5 is positive. S1 into cos 45 is also 45 positive. Only two forces are involving along x direction. S5 plus S1 into cos 45 equal 0. Algebraic summation of forces along y direction equal 0. Vertically upward direction force considered as positive. From the free body diagram, RAV is directing upward direction. S1 into sin 45 is directing upward. So these two forces are positive. RAV plus S1 into sin 45 equal 0, where RAV equal to P. From this equation we can find S1 value very easily. S1 equal to minus P divided by sin 45. When you substitute S1 value minus root 2 into P in the above equation, we can get S5 value very easily. S5 equal to P. By following obtained results of S1 and S5, S1 is negative, that is minus root 2P, S5 is P. Negative sign indicates as compressive force. Positive sign indicates as tensile force, which will be generated within the members of the truss. Considering free body diagram of joint D, apply the equilibrium equations along x direction and y direction to find the unknown axial forces S2, S6, S5 in terms of known force P. In the previous derivation, considering free body diagram of joint A, we have estimated S5 as P. In the free body diagram of joint D, four forces are acting. One is P acting downward direction, another is S5 equal to P, it is directing leftward direction, S6 is directing rightward, S2 is directing 60 degrees incline with a horizontal. As this S2 is inclined force, for this inclined force we have to find horizontal component and vertical component. Horizontal component is adjacent to 60 degrees. Vertical component will be opposite to 60 degrees for S2. On applying equilibrium equations along x direction and y direction, we can get two equations of equilibrium. When you consider summation of forces along x direction equal 0, we have to get S5 force in the equation of equilibrium, S6 and S2 into cos 60. S5 is directing leftward direction, take negative sign. S6 is directing rightward, take positive sign. S2 cos 60 is directing rightward, so it is also positive. Then after, apply summation of forces along y direction equal 0. On observing free body diagram of joint D, the number of forces which are acting along y direction is 2. One is P which is acting downward direction, another is S2 into sine 60 degrees which is acting vertically upward direction. When you apply summation of force along y direction equal 0, we can get these two forces in the equation of equilibrium. The force which is directing downward considered as negative, the force which is directing upward considered as positive. From this equation we can find S2 value very easily. The magnitude of axial force generated in S2 in BD member is positive, so it is tensile in nature. When you substitute this S2 value in the above equation, we can get S6 value. The magnitude of axial force generated in DE member is S6. S6 exactly equal to 0.423 P. It is positive. So it is tensile in nature. To find the other axial forces S3, S4, S7, we have to consider separate free body diagram of joint E and apply the equilibrium equations along x direction and y direction and solve them to find S3 and S7. Then after considering free body diagram of joint C separately, apply the equilibrium equations along x direction and y direction so that we can find S4, S7 in terms of known forces.